Like Rick said, I was here 2 years ago with Brian Bartholomew, my partner in crime at the time, now solo. But you know, hopefully next time I can drag him out here because I've never seen somebody get as uncomfortable with my slide making style as him. So he makes for a very good partner. So my name is Juan Andrés Rosade. I'm now doing research over at Chronicle. I hope that you'll get to see a lot more of the work that we're doing. But in any case, I wanted to have kind of a different kind of conversation, maybe land a little more practically, maybe give you guys a bit of a guide of how some of the more accessible advanced research can be done, but also do a bit of a call to arms for researchers. So I hope that that can be interesting to all of you. So, like I said, let's talk about research methodology. Okay, I'm not going to bore everybody in the room. I made Rick a promise that despite the fact that I would be able to talk about methodology and technical abstraction all day and you know, pop out some 30, 40-page paper that nobody wants to read, I'm not going to bore all of you to sleep, especially after lunch. So instead, for those of you looking to be bored, you can find the last paper I wrote on this. Apparently, the caps are important, so you really have to scream the 3 cybers, and then you can find the paper there. But instead, let's discuss the problem with APT research cycles, which is really what I want to get to. So research does a lot to improve collective defense. I think there's very good reason for having research teams out there. There's very good reasons for having research publications out there. It might not become immediately accessible why it's good, but in the end, you end up doing a lot to protect the general ecosystem. The thing is, new discoveries end up expanding the horizon of what we consider possible or probable. And that's particularly important when it comes to having threat models that are responsive to the actual threats that are out there. If we don't actually think that something is possible, or if we don't actually think that something is being exploited and used in the wild, we're a lot less likely to think that that is in any way relevant to our organization, our enterprise, our concerns. The thing is, well, let me point this out. It also does a lot to point out the right experts for you. Like Joe was just here on stage. The truth is that if you have an ICS intrusion, as much as I would love to know about it, chances are Joe and Rob can do a lot more for you in that moment. So, of course, you know, send us some hashes, but those guys know a lot better what to do with your environment. So it's good to have points of reference for who are the people that are interested in that kind of research, who can competently deal with it. Chances are maybe a lot of us can, but some folks are already involved in that. So it does a lot to flag that for you. However, while research discoveries do a lot for defining and scoping our threat modeling, it's actually threat tracking that fuels long-term defense. So what's the problem with that? The problem is hit-and-run research. This is something that I've been bitching about recently. You may have already heard me bitch about this on stage. But essentially, the incentives are kind of problematic when it comes to the type of research that we're publishing, how we're publishing it, when we're publishing it, and when we keep doing it. If the research value is PR value, then essentially tracking something old, something that is already known about, something that's already been a story and had its 15 minutes, it's no longer worth anything. So there are some cases where, you know, very competent research was done and it burned the tooling to such an extent that that actor just sort of dropped off the face of the earth and there's no point. Okay, fine, I'll give you that. But in most cases, what ends up happening isn't that the actor becomes less active after publication, it's just that all the researchers have moved on. Said, okay, it's out there, APT 10 got, you know, Chris McConkey, the handsome man that was up here earlier, he did some great work on CloudHopper. That became the year of CloudHopper, 2016, if I'm correct. Everybody published on CloudHopper following PwC's lead, and then it turns out everybody stops looking at CloudHopper for at least a year or 2 years because that story is burned. But that doesn't mean that the enterprises that are concerned with CloudHopper or APT 10 have to be any less concerned. So to be fair, those misaligned incentives don't apply to everybody. The truth is that if you have 6 figures that you can use to pay for private reporting, then you can always ask for a certain amount of coverage. That said, if you can't afford that, you know, you're kind of on your own. And that doesn't really sound right to me. That's not really how we should go about some of this stuff. But it's not enough to complain about it. So what's a better approach that we can take for this sort of thing? I think that it's important for us as researchers and for all of you as consumers to start demanding the proliferation of the means for sustained tracking. By that, I actually mean that it's important to have the adequate tools, to have the adequate methods, which I think a lot of the conversations up on this stage today have focused on having the right kind of methodology to go about this research. And I also think it's important to have the right insights. And insights is kind of where we're failing a lot right now. Like, there's a lot of great tooling out there, especially a lot of things that people already have access to, things like domain tools, passive total, virus total, et cetera, that you can go and get great data that is actually what researchers are using to base themselves off most of the time, as long as it's not their proprietary data as well. But you don't necessarily have the insights that connect the pieces of that operation with their conclusion, the pieces of that operation with each other. How did you jump from this thing to the other one? How did you find this other thing? How does that allow you to track these people further even when their tooling changes slightly? So that's some of what's missing. That said, there's a caveat in there, which is you want to publish this without disproportionately benefiting the enemy, which is something that also happens. But we can talk about that at the bar. I'm not going to name anybody or name and shame or anything of the sort. But there is a complex calculus that has to happen in saying it's better to provide this to people to track versus if I do this, then the one piece we have to track this actor will be changed, and then we're all screwed. So there is a certain need to provide access to expanded metadata queries for better tracking tools and means of correlating diverse signals. And I hope that, as the year goes by and a lot of tooling comes out, that we'll be able to provide that others will be able to provide that. You can go talk to folks at the booth. I'm not here to sell anything. Instead, what I want to do is focus on motivating researchers to change their focus, to get away from that notion of hit and run research. And a lot of the people that can motivate that to happen are in this room and are in this industry more on the consumer side. Right now, our main consumer as researchers tends to be folks in PR. It tends to be reporters. It's Kim Setter and Sanger and the rest of them, and you want them to, for their eyes to fly open when you say, oh, we found this thing. So the only thing worth writing about is something that's going to interest the media. And sadly, what interests the media isn't necessarily what's going to do anything for anybody that's actually supposed to be defending an enterprise. I also want to kind of lift some of the mystery around some of this research in the hopes of some of you will feel motivated to also take it on, to not feel as intimidated by some of the big boys, not feel so intimidated by doing some of the research. And for that, I hope to get into some of the granular bits. I can't really get into all of it. As it is, I have 120 slides for 30 minutes, which is ridiculous. But I just want to, it's not a joke. I told you, you're my mentor. You were supposed to sign off on these slides, Rick. So,
you never sent it to me.
Fair enough. I didn't send it to him. I had a feeling he wouldn't like that. So, part of the motivation is, the newest, latest, hottest, newsworthiest thing shouldn't be the only research worth chasing. And it really isn't, not if we're trying to do collective defense. I have to admit that I'm biased. I'm actually a big fan of this school of cyber paleontology, something that Kostin Ryu coined and that I've tried to work on with him. We worked on Moonlight Maze, which was a 21-year-old intrusion set. We like going back all the time and looking at different things that Equation did back in the day, that different parts of Flame, Dooku, and all these different people have done back in the day. It's always really fascinating. Sometimes it's hard to explain the value of it, but I think that if we look at this as more of a history of humankind's going into the fifth domain, there's a reason why you want to document these things, even if they're not immediately apparent in their value. So it turns out that no matter how hard our best and brightest may try to cover something, there's always more to be discovered in hindsight. And that's really important to understand. There's really impressive research done by people far smarter than I. But if you go back, you can always find a little something more. And that's not just out of luck. You have to remember that time is a fickle thing. It greatly benefits attackers in the short run. We don't know what we're going to get hit with. We don't know if we're being targeted. We don't know what we're being targeted with or when. But in the long run, it actually benefits researchers. You have to remember that there is this sort of anthropic process to it. I did probably steal that saying from the Grug and kind of bastardize it a little bit. But think about it. Attackers can't go backwards and expunge whatever signals and artifacts were collected in our telemetry. They can't go backwards into AV collections and remove the malware that was picked up. They can't go backwards and remove whatever telemetry was picked up, whether it's honeypots, EDR, whatever it is. That's stuck in some collection somewhere. So while they may have gotten away with an attack in the very beginning, whatever happens in the aftermath, once they've moved on, that is sealed there, like bones, fossils somewhere. And that's where we get to do some of our best work. They also can't stop the progress of technology, which is particularly important to our industry. They can't stop our tooling, our sifting methods, and the general computing prowess that gets put into the threat intel industry from drastically improving over time. And I do mean drastically. I think it's really hard for us to keep perspective in threat intelligence because so much happens so quickly, and so much of it has kind of gravitas and weight, and we think that this is so significant that it's been happening for a long time. But the truth is that the threat intel industry in the private sector has only really been going on for something like 8 years. Kicked off by a lot of the work on Stuxnet, a lot of the work, Mandiant with APT1, Symantec and Kaspersky with Stuxnet, a lot of interesting things that only happened 7 or 8 years ago. And that's not a very long time for an industry, especially an industry that's a subsection of computer science. So I want you to think back to something that I call the embarrassment of riches period in APT research. And I think that it's a particularly important one because if we remember the context, malware analysts back in the day, our malware analyst forefathers, all they cared about was crimeware. And it's not because it was the only interesting thing, but it's because it was the only thing they thought was actually happening at the time. Remember what we talk about with threat modeling, right? At the time, they said it is very possible for somebody to use malware to spy, but it is not an actuality at this time. It really isn't happening. We've yet to see governments go into this sector. So all we're focusing on is banking Trojans. And then came Stuxnet, right? The big shot across the bow, and everybody lost their minds about what was happening with Stuxnet. But then came Dooku, and then came Flame, and then came Miniflame, and then came Gauss, and then, and now it turns out that we have a different APT every other week, and they're everywhere. And that's something that we have to keep in mind. It's not that these operations exploded in that more of them started to happen. They were already there. What changed is we became aware of something. We became aware of the shape and form of something that had already been happening. And then we proceeded to hone our tooling and our concepts to unearth its likeness. We essentially caught the scent of this thing and started to chase it down and find more and more of it that had been happening for 5, 6, 10 years, already inside of our collections, already inside of our telemetry. We just didn't know what we were looking for at the time. So keep that in mind, and keep in mind the context of what was happening in technology at the time, what was happening in tooling at the time. They didn't have Yara, which is, how many of you are using Yara right now just to track malware? They didn't have Yara. There are no public Yara rules for Stuxnet, Flame, Miniflame, Gauss, Dooku, any of that stuff, because nobody was writing them at the time. There were no retro hunts. You weren't going into VirusTotal and essentially saying, hey, search this repository for me for X amount of time with this rule. There was no cloud processing of petabytes of metadata. Nobody was going and saying, you didn't have access to these thousands of servers that were going to be able to sift through information for you. It was essentially just the AVs using decades-old technology that they'd clumped together into these Franken monsters on your endpoint, and still managing to do cutting-edge research and tussling with these beasts in different ways. And that came out with this amazing research that we found. That said, I think that with all the stuff that we have now, with all the perspective that we have now, with all the understanding of other operations that we have now, with all the capabilities that we can use from our very own personal computers at this time, and all of the information sharing that is happening, we can actually get better results when it comes to even the exact same pieces of research. It's just a matter of having the motivation to go back in a lot of ways. So instead of chasing the hottest, newest, most newsworthiest bullshit that you can get your hands on, whatever latest run of Cobalt Strike being used for financial whatever, let's instead take that cutting edge tooling and revisit some of the old mysteries. And the truth is that there are unanswered questions when it comes to all this stuff. And if you read really closely, like Katie was talking about like processing through old reports and like taking it for the attack framework, and it takes a lot of time just to be able to do that kind of granular understanding of a report. But if you get familiar with how researchers are writing these reports, you'll actually start to notice when they're skirting around open questions that they don't want to answer. And it's not that, sometimes they don't want to answer it because it's political stuff that you don't want to talk about, but sometimes you just don't want to admit that you don't know the answer. I don't know. It's really, like, it's fairly unacceptable in a publication these days to just say, I have no idea why they did this way. But a lot of times we don't know, and those are unanswered questions that I wish were documented more clearly. There are many unanswered questions when it comes to a lot of different operations, and those are exactly the points at which we should go back a year later, 6 months, a year, 2 years later, and say, you know what, with this new telemetry, with this new capability, let's figure out what the hell is going on there. So I also promised Rick that I would not overwhelm the crowd with examples. I think being a pit master, he told me that there was too much meat in our last talk, so this is more of a salad, if you will. It's just one slab of meat. Now we're going to focus on one hopefully good example. And part of that is I want to take a little more time to illustrate some of the process that went into it. Not all of it, but some of the process, so that hopefully we can get some of the folks that are feeling shy about approaching some of the more complex operations to feel like they can definitely take them on or take on pieces of it. So let's lift up some of the mysterious fog from some of it. So being in DC, is anybody familiar with the Lamberts? There we go. Let's see. Thank you. I got a friend in the crowd. So the Lamberts, for those of you that don't know, this is kind of what it looked like when we first published something publicly on the Lamberts. Lamberts has been something that I worked on for years, and it takes a very long time to get on top of the iceberg that is the Lamberts toolkit. Because in reality, what we're talking about is about probably a dozen different custom modular frameworks worth of malware. All of them advanced, all of them very well made, very carefully distributed. It is a very difficult APT to track. I would say it's one of the most difficult APTs to track. Not the most, but definitely up there. Part of it, and this is where the sort of big unknowns come in, the known unknowns. For the most part, we don't know what their infection vectors are, which for something that has been active for something like 10 years, that's a very daunting thing to think of. We don't know a whole lot of their infection vectors. We've identified maybe 2 or 3 out of all the malware anybody's ever seen for these guys. We also have very little understanding of how they orchestrate victim box operations, which is to say, what happens once they're already on your network. Sure, we see this really complex, sophisticated piece of malware that's there, but how is it operated once it's in there? A lot of them don't have CNC communications, so how are they patching them, fixing them, updating them, moving them around, deleting them when they need to? It leaves these very big open questions, right? So those are 2 that we're going to try to address in a sort of simple, quick manner, right? So how do these implants get on the victim boxes in the first place? And how are the artifacts orchestrated, patched, updated, controlled? So a brief rundown of 2 Lambert frameworks, just so that you know what we're going to be working with. There are a lot more. A lot of them are privately reported, so you might not find as much reporting on them right away, but you can at least find a couple of blog posts under the Lambert's toolkit or Longhorn, which is what Symantec called them when one of the relevant leaks came out. So the first one is Black Lambert. This is actually the first Lambert that was ever discovered. Credit to FireEye for finding the first one. They reported the 0-day, but never reported the payload. So they actually found the very first Lambert. What's interesting about it is this is one of the 2 infection vectors that we ever discovered, which is an ODTFF 0-day exploit, which is to say a font parsing vulnerability. Those are fascinating because it means that something in the kernel isn't processing the fonts correctly. So you just open a PDF, you open a Word file, you open whatever it is, and it's straight to kernel or arbitrary execution. It's fascinating that they can do that. And these exploits are particularly rare, to the point where before that, that style of exploit had only been seen with Dooku. So when they first discovered this, people thought that it was another Dooku, and it wasn't. It was, in fact, the very first Lambert that we saw. It was a modular framework designed for espionage, and the payload was entirely in memory, so it was particularly hard to catch. It also had all these funny quirks, like it was hard-coded for a server within the perimeter of the intended victim, so they were doing all kinds of sophisticated movement inside of that environment. There's fun stories around it, but that's not a story for today. Another framework that we're going to look at is White Lambert. This gives us our other question, right? So White Lambert is a kernel mode passive implant. That's to say that it is not beaconing out. It is not giving you any signals that it is there. And those are particularly fascinating, right? Like if you hone in on beaconing within your logs, then you go, oh, well, I'm going to know any malware that's there, because why is this thing calling out every 5 minutes from somewhere that it shouldn't? Well, in this particular case, it's not going to call out to anything. It's going to wait for the right thing to come along and trigger it. The whole point of White Lambert is that it's this kernel mode implant that's supposed to help orchestrate a series of infections. And that's quite fascinating. You say, well, they're only going to connect to one machine. That one machine is going to send signal to one place, and that one place is going to orchestrate 20, 30, 300 infections on a network. And they're going to have this sort of unicast, multicast system to manage themselves around. Nobody knows what the delivery mechanism is for White Lambert. And it was later on replaced by Gray Lambert, which is userland, because 64-bit code signing made it quite complicated to have these sort of kernel mode components after, I want to say, Vista or Windows 7. Somebody can correct me on when 64-bit code signing in Windows was introduced. So keep that in mind, right? I got bored on a Friday night, and I don't really like stepping out or seeing light or people, human beings, interacting or anything. I'd rather just track some of my favorite threat actors at that time. So I was like, well, let's go look at some of these old samples, right? So I put up some of these White Lambert samples on a new system that at the time was experimental for us. It's now been proliferated to a lot of people at VirusTotal. You can go and play with Graph and play with some new similarity engines, and I hope that, if you haven't done it already, go bug the dudes at the booth and, sound important and say that you need access to everything. Hopefully that'll work. I don't know. So I stumbled upon something odd. I put in some of these old samples that we knew about, and the similarity engine immediately spit up 2 other samples that were entirely undetected. So right there, simplest, cheapest pay dirt ever. I did nothing. I put in a hash, I double-clicked on a thing, and all this machinery, expensive machinery, told me, hey, there's 2 other samples. And what was interesting about them, it's not that there are more samples, it's that they were fully undetected by the AVs, which means that those generic detections aren't, there's a similarity engine that's telling you that they're similar enough, but the generic AV detections aren't picking it up. So this is the kind of thing where you go, oh, well, let's take a minute and figure out what the hell's happening in there, right? So one of these samples, one of the new samples was particularly interesting, was actually the parent, the compressed parent of where that sample came from was a RAR archive. That I've now figured out was actually from an incident response engagement where it looks like the IR guys just had no idea what was in, what they were finding, and they just uploaded the full archives to VirusTotal. And I'm hoping that helped them at the time. It at least helped me give you this presentation, right? So if you look at the name, there's something that should stand out. Let's all be sleuthy and kind of play around with this. You go, well, 123. Part 003 of a RAR. Well, it can't be that simple, right? You go, I don't know if there's a 4th, but there's at least got to be a 1 and a 2. So then, this sparks joy. You just start subtracting and file name searching, and it turns out that that's a fairly unique thing. And even though, these RAR archives are encrypted, if you have all the pieces, you can actually rebuild. So in there, we find something entirely different. It's something that calls itself like a substrate piece of malware. What I'm missing from this picture is actually the similarity engine, once you point that out, actually connects that back to some of the earlier samples. So right there and then you're like, okay, we're pay dirt. Even though there were about 20 or 30 different binaries in these things, they just pulled everything out of System 32, right? Let me speed up a little bit. So this thing calls itself MSDLL fix, which right there and then, for those of you that know what spear phishing is like, what it's like to get these attachments and things, it should start to spark some concerns, right? This is actually one of the other types of infection vectors that we discovered for the Lamberts. They'll find you on just off the top of my head, a forum for research on building the kind of tunnels that nuclear plants underground might be interested in building, asking for software that is currently under embargo in certain countries, and then somebody shows up and says, oh, don't worry, buddy, I've got it for you, and they just kick over a binary that doesn't actually have the thing inside of it, but it does have something called blue Lambert. So what we found is something that I like to call Tuxedo Lambert. This is entirely new. Nobody's heard about it before. I just bring it to you guys so that we can have some fun today. I call it Tuxedo Lambert because it actually has similar encryption and export styles to Black Lambert. And if you remember that ODTTF exploit that Black Lambert was discovered with, what Tuxedo Lambert does is it sets up a service, it drops its own font, which is not vulnerable when you first see it. It alters the font into a vulnerable state. It exploits what at the time were 2 0 days in the Windows kernel in order to load something directly into kernel memory. And when you look at what that is, it was white Lambert. So that's our second question there. Once you figure out, like, this is what they're doing as far as loading up their sensitive implants. So this particular, white Lambert was particularly sensitive to this orchestrator thing. We never knew how it got there. It turns out they rely on another entirely sophisticated dropper. That all it's supposed to do is create something exploitable within itself in order to load this thing up. So, like I said, white Lambert, we now have an answer that's more of a question in and of itself, but essentially, Tuxedo Lambert is the infection vector for white Lambert. What the infection vector for Tuxedo Lambert is an answer for a different talk, presumably. So what happens to the other question, right? Victim box orchestration. How the hell are they doing these other things? Well, it turns out that once you hone in on something like 7 or 8 Tuxedo Lambert infections that we found, there's a tiny file that keeps showing up whenever these things show up. And that tiny file is actually a custom web shell. So if you think back to old school hacking, the way that people used to do it before they relied on all this automated command and control nonsense, the good old hardened hackers, a web shell and some command line, hands-on keyboard way of managing infections. So interesting things about this web shell, it's a no-nonsense, very interesting, tiny piece ASP that what's interesting to me is it actually requires authentication to issue commands, which is something that I've promised to write a paper about but haven't. It's a Nobus style of backdoor. Nobus is a term that got popular around the Snowden era, and like most things in the Snowden era, got unpopular about a month after that. So it means nobody but us. It's what responsible threat actors do. They pop your machine, and just because they're there, it doesn't mean that everybody else should have access to your machine. And what's interesting about this web shell as well is that it actually monitors for attempts to be researched or abused. So again, they're watching to see what we do, but also they're trying to make sure that nobody else is exploiting their own technology to enter your box. And as is often the case, and this is particularly important to understand, once we discover one thing, we discover many things. So that's, yet again, going back to something that seemed uninteresting, that seemed beaten to death, finding a few pieces, finding a few answers, and then finding a few new questions. And that's the beauty of doing this sort of research, of going back, understanding something more fully, using tools that were not available when we first discovered Black Lambert and White Lambert, and are now proliferated to just about everybody in this room, and finding a lot more things. So that's kind of my pitch, trying to get all of you into this cyber paleontology train, of trying to get all of you to feel less daunted about taking an old report like the Stuxnet report, like the APT1 report, like whatever it is that you're into that you find fascinating. Taking those IOCs and start beating them, beat that dead horse again, and you'll find something, I promise. And just in case you need some research leads and some fun stuff to do, you can always help us find the milk carton APTs, as I like to call them. Things like Flame, which was never seen again after its original discovery. Careto, still missing. Its family asks about it all the time. Babar, the snow globe APT. Lots of interesting stuff. All of them fascinating. All of them with plenty of open questions. And where there's that, there's a lot more to look for. So somehow, 45 seconds to spare. I should have added like another 50 slides, but that's my piece.